Hello everyone, welcome back to our CSCI for 30 operating system. And today we'll continue about the topic about the multitasking or multi-programming of the OS design. Okay, so in our previous lecture, we kind of start by what's the multi-programming and then compare with the time sharing. So we compare one is the principal objective. Once they try to maximize the processor use is a batch programming. Okay, and then for time sharing is they try to minimize the response time. And then the second one is the source of the directive to OS. So one is for the batch is a job control language command. Okay, and then for time sharing, the command enter at the terminal. So here's the differences. Okay, and we kind of summarize it in this way. And when we move on, we will still go through more just more information. So we try to understand the importance and be able to explain the major achievement in history of OS design. Okay, so you see maybe not really just some information. Okay, so if you remember kind of the development of different OS version. Okay, so right here we say we getting more complex, right? Because the source code based on when I start by the Vista, but actually after the Windows 7, okay, Windows 10, okay, or the Windows 11, okay, even others Ubuntu or even the Macintosh, the Mac OS too. So actually all these source code actually already increased a lot. So right here. And the major achievement including the process, the memory management, okay, also the information protection and security. So if you remember, for the protection, including we talk about the process to access to those share resources. Okay, so how can we do the protection? And then also the scheduling resource management. Here is the really key and important knowledge related to operating system. Later, when we learn more about process, okay, and then about the scheduling or how can we manage the resources, and you have some exercise to do it, okay, and also your assignment, we will work on this, and move on to the first achievement is the process. So it's a fundamental to the structure of the operating system. So we try to provide some fundamental abstraction. If you remember abstraction, also allowing some multi-programming to work. Okay. And then the next one, we try to simplify application program point of view. Okay. Illusion of the complete control of machine. So like this, if you remember, when we go back to the process in the beginning, see point of view, if you remember kind of in the beginning, when we talk about the interface right here, abstraction, and information right here. So if you remember, in the beginning when we talk about that, the OS as resource manager, okay, abstraction right here. So giving the abstraction, so maybe the process virtual machine. So they're thinking the process, thinking even they share the resources, but they were thinking they own all the memory. Okay, so all the memories or own all the devices. Okay, all this. So it's the called the abstraction. Let's go back to here. So this is the first achievement for the process. Okay, but we need to think about sometimes there's some causes of errors. Okay, before the process abstraction. So what are those possible errors? Okay, so when's the improper synchronization? So when here, if a program, okay, they must wait until a date available in a buffer, okay, or some kind of improper design of the signaling mechanism. So also can cause like in loss or duplication. So here is called the improper synchronization because they need to wait for it. Like when we talk about buffer, okay, let's say we have the I/O devices, right? Or when we're reading something or writing something, we write into a buffer. If you learn C++ before, we sometimes create a buffer to read or write. So this one is by means of buffer. So we kind of like waiting for it. Okay, and also the second one, we talk about the fails of like mutation exclusion. So is they say, okay, more than one user or programmer tend to make use of a shared resources at a time. In this moment, maybe you still have no idea, like, but just imagine it. If you have just make it simple. I say putting RAM because of memory or somehow I say if we have one resources and then we have like two user, okay, and they will try to compete to use that resources, and then how can they share at the time? Okay, who go to grab it first, and then second who be the next one? Okay, or like do we have any mechanism? Okay, how can I check when this resources being released or like when it's available? So it's a is an issue. Also, we need to think about that. And also, there's only one like routine at a time, so allowed to perform an update against the file. Okay, so here's another possible is they failed the virtual exclusion, and and then the third one is the non-determined program operation. So if the program execution they are like interleaved by the processor when the memory is shared. Okay, but you know, of course, you know, after you have some idea when we went through how the introduction, so you know, like we share the memory, right? Share all these resources. So if they like is interleaved by the processor, then it maybe have a non-determined program operation. Also the order is like which program their schedule may also affect their outcome. This the OS, like what the OS like need to do is like how to scheduling the process, okay, how to let the application like take in term like maybe time sharing, time based, or we do have different mechanism, okay, make sure. But right here we just thinking, okay, just asking which program are scheduling will affect their outcome, okay. And also here's really key or I say important, we mentioned it's called deadlock. Okay, so is it possible like two or more programs that are like they're hang up waiting for each other? If we have one resources or like maybe there's some implementation um error or like logical error, whatever. Okay, so maybe they're waiting for each other. Okay, but one is like waiting for resource, one is waiting for the feedback result outcome. Okay, so they are waiting. Okay, they cannot take like move on to next stage. Then they will occur the deadlock. Okay. Also, it may also depend on the like chance or timing of the resources allocate and reload release. Okay, cause it so as a referee or like we talk about that like OS, so maybe how to manage it, like the resources. Okay, that's that we always try to predict or like calculate what's the next stage. Okay, is it enough? Later you will learn about that. Okay, how can we do the calculation and how can we predict? Is it enough? Then we allocate the resources. If no, then we maybe not going to do that. Okay, but it may be possible, okay, in certain stage, okay, because you never know, like sometimes in some application programs, okay, they didn't really tell the OS that well, then it will cost that lot. So boost screen, that will always let you see the boost screen, okay, when it happen, is the possible error that it occur. And when we talk about the components of a process, so it contains like three components. One is an executable program. Okay, so if you look at the memory like stack, so you will see like one's an executable program, and then of course we do have some associated data. Okay, so need by the program. Sometimes if you see, okay, or when you wrote the C++ program. So you see we declare some variable, right? So maybe you like calling the library, import something um, maybe some constants, whatever. Okay, those variables, so we need to use them some workspace, okay, buffer, okay, etc. So those that associate data, okay, will be the components of a process. And then the next one is the execution context. That means the process stage of the program. Okay, so where's the stage of it? Why we need to have all these processor? In this moment, we have three components, but later when we talk about scheduling, okay, how to manage, then you will have a better idea knowing how these components helping for scheduling. Okay. And in the scheduling context, why you say is essential. One of the reason is that the internal data by which the OS is able to like supervise and control the process. So it's one thing because we talk about the stage, right? If you remember, there was a cycle with the stage. So right now, maybe you're waiting for input, okay, or you're like in execution state, okay, or we just like on hold, okay, okay, whatever. So we are waiting for the interrupt. So we know the stage, and then includes the content of the various process register. Okay, you know the registers. So what's the content inside, and also the information such as the priority of the process. Um, this one also related to the scheduling because the priority of this process will affect. Okay, later when we learning scheduling, we say okay maybe some process have higher priority, then we need to execute it earlier. Okay, like this, whether like it's waiting for the completion of a particular IO event, somehow like that. So here's the component of it, the process. Right now you just need to know we do have this kind of components. Later you will have a better idea. And so far right here, when you look at the process management right here, so right here is showing if there's an entire state of the process at any instance, so there contains in its like context. If we have the process list, like here's the main memory, that means it's a RAM if we learn, and then we have the process list, and this process list point one is the context. Okay, we do have data, some program code if you remember, and then we have process B, context data program code. So here's the components, right? And when we have the some program address space, so right here we do have some like process register, including the PC. If you remember, if you're working on the assignment, also you see that was the program counter. Okay, maybe we have them basically later. You also like when we talk about memory, you will know more like about sequence. Right here, when you see the program address space, so we have a stack, so we know like, and we have some heap containing it, and then we have the data, and then some code right here. There's a new features. Okay, also can be designed and then incorporated into the OS. So by expanding the context, so including any new information needed to support the feature. So also it can be doing in and then here. So it's so far here would be the process management. So far more about the process. Okay, so is a unit of resource allocation and then execution. So later we'll using say process A, process B. So all these like we say is a unit of it. So it owns a memory. So it do have a address space if you see right. So we do have address space. And actually more than that, we have like also file descriptors, some file system context too. So also encapsulate like one or more like thread sharing process resource. Later we talk about like multi-threading. Okay, all this. So right now we just need to know we have like more thread sharing process resources. So why like processes? Okay, so we're going to like navigate. Okay, the fundamental like trade-off between protection and efficiency. So as well as say when we're learning computer science or like related to computer, so we always have trade-off. So why now why here say okay, if we want to have better efficiency, okay, maybe we need to lower the protection. If you want to have a fire protection, higher protection, that means you maybe lower the efficiency. Also, processors provide memory protection, so while the thread don't. Okay, so right here they because like threads they share process like memory, right here. And also the third more like efficient than process. Okay. Later we talk about it, but in this moment you just need to know, okay, so what's the third? Okay. And also the application instance. So they consist one or more processes right here. Okay. And then you need to know one of the like some basic problem of concurrency. Okay, we talk about the concurrency of okay. So concurrency, what's the basic problem of it involve the resources. Once the hardware, if we do have only that one single CPU, single RAM, or a single IO device. Okay. But how about multi-programming? We talk about the API, right? API. So the process thing, they have the exclusive access to share resources right here. Just remember if you remember. So, and then also the OS, they also has to like coordinate all the activities, like because we have a multiple processes, and also we have like a lot of different IO interrupts. Because when we talk about IO, different type, like let's say your keyboard, mouse, printer, scanner, okay. So all these things maybe. So how can we like keep all these things like straight? So there's a the how important of the OS. Okay, maybe we can give a basic idea. Just thinking maybe just using the virtual machine abstraction. Okay, if you remember the abstraction, simple machine abstraction. So for the processes and also like multiplex, this like abstract machine. So also we can do it in this way. So here's the kind of the basic problem of the concurrency. And how can we give the illusion like, of a multiple process? We just think about that. So because they all have, we share the memories, right? So maybe we have the virtual CPU 1, 2, 3 right here, and then they will go through the time 1, 2, 3 and go back 1, 2. So we can assume if there's only single processor, then how can we provide the illusion for multiple processors, like multiplex right in time? And if each like virtual CPU needs the structure to hold, so including the PC, stack pointer, so why not just need to know, and then register, including like integer, floating point, all this. Then how can we like switch from one virtual CPU to next one? And then maybe we need to save the PC, SP, okay, and register, okay, in the current stage block, and then load the another state block, and then those like PC, SP, and register. Okay, so how can we trigger the switch? Like maybe sometime like timer, voluntary you, and IO or other things. Here we talk about that. Actually, for programming, if you're learning multitasking, okay, multi-threading, okay, all this, but we're switching from process to another process. Okay, so we need to save the current state or save it. So we sometimes we put a stack. So we say save the PC. Okay, maybe the stack pointer or the registers of processor A, and then we will even interrupt to like actually they're all pretty similar. Okay, so just need to know pretty similar idea. And then when we move on to second achievement, we talk about the memory, right? So management, so we have 5 principal storage management responsibilities. Once they process isolation, we kind of mentioned about this one before, and automatic allocation and management, and support of the modular programming, protection and access control, pretty similar, and also long-term storage. So will be total 5. Okay. Of course, we'll go down and talk about this like later. And another one is called a virtual memory. Okay. So it's a kind of like facility allow program to address a memory from local point of view, and then without requiring to the amount of memory physically available. So what is the meaning that virtual memory? We have a main memory, right? The RAM. We do have limited size. Maybe if we trace back, maybe like 4 GB, 8 GB, 16, 32, 164, 128, whatever. So if we don't have enough, you just imagine it was a memory. Memory is just like your desktop, okay, your desk. Okay, how big is your desk? Then you can put how many things on it so you can like work on it. Okay, so if you have larger table, okay, your desk is have more space and area, then you can put more space on it. Okay, And we do have a second storage. So what's a second storage? Let's say your hard drive. Okay, we still use hard drive, but nowadays we're using like SSD. Okay, and we're using part of the hard drive. Normally hard drive more space, then we can use it treat as a virtual memory. Later you will learn like how can we swap it um between like virtual memory and main memory. This one you in this moment you just need to know this keyword virtual memory. So this virtual memory is just like taking space of our storage. Okay, so pretending. So kind of extend your memory. Okay, just bringing your table. Okay, but one thing is like the speed. They are not the same. Right? If you remember, the fastest one is the cache and then memory and then second storage. Okay, so we need to know. And also we need to know like concept to meet the requirement of like having multiple user jobs reside the main memory concurrently because we have not only taking care of one job. We talk about really long time ago, like in the history, the first time we only work on one application. Of course, it's okay. But when we do multi-programming, like when we talk about multi-programming, then maybe we have some multiple user jobs beside in the main memory concurrently. Then how can we maintain them together? So we need extra memory. So we can use virtual memory. And then keyword, that's what we learn, like how it going to works, paging. Okay, so paging is like allow the process to be like compressed of the number like of the fixed block, fixed size block. So we call it's called page. So a program references a verb by means like of a virtual address. Okay, so it consists of page number and offset within the page because we need to know like what's that process like or that program beginning to that. So we need to know the offset. And each page may be like located anywhere in main memory. Okay. And it try to provide a dynamic like mapping. So when we are paging, then we have dynamic mapping between the virtual address used in the program and then a real address in the main memory. So try thinking, okay, if you have a program, okay, and then your program have an address, let's say line 10 to 12 is a for loop, okay. But actually, when we put this application on the main memory, maybe actual address is not from 10 to 20. Okay, so it's somewhere. Okay, and that's why we need to have the offset. So know, okay, what's the beginning point? So what's the actual address and then plus the offset so we know the size. So for in this moment, you will giving a picture like showing kind of right here. Wednesday is we have a program, we have a code data like heap and stack, if you know. Okay, so maybe we try the translation map and then you see something we're putting it in somewhere like data to right here, stack one, stack two, data one, heap two, code two. So they are like kind of like putting right here in that program. Okay, so on a really physical address space, you will see they are not like um allocate together. Okay, so they're going to put in different location. So that's why we need to have like paging, and then sometimes we need to have the offset to show okay from what's the starting point and the offset, so you know when it's going to end. So here's the idea of it. And then third achievement is the information protection and security. So when the computer didn't contain some like critical information, fine. But if the blue screen of that way, you know, right here. So the network and breakers computer, so they embed system, so they have the concept for protection of information. We always talk about the availability, okay, confidentiality, okay, data integrity, and also authenticity right here. So always when you learning cybersecurity or other topic, we always talk this. Okay, so that's what we need to always make sure. Okay, right here when we try to protect the information and security. So kind of related to it. So all these like pretty similar idea. And just like make sure like right here is like available always like when I access then I can read it, write it, and then confidentiality, like who can maybe including the users, like who can have a right integrity, make sure like when we modify, okay, make sure they are like same identical, okay, and also like who have a right, so giving a permission, which user or groups can access the data, so all this idea. And then the fourth achievement is the scheduling and resource management is really key in responsibility. So that's what we're going to learn. Okay, the following few or the lectures that we're talking related to scheduling and resource management. So here's the major achievement in the memory. We talk about like memory because we need to know. And so the processor scheduling, resources management. So allows like much better utilization for three factors. Okay. So what's the fairness? Okay. How can we make sure if we have 10 processes? Okay. How can we make sure they being like fairly like processed? Okay. Differential like responsibility, also with responsiveness, okay, right here. And so efficiency, okay. We do have different mechanism how to like measure or like for the process and make sure they have like better efficiency. So sometimes we're looking like maybe utilization, like maximize the throughput, or how can we minimize the response time, all this. Depends on the design, okay, or like or actually it's kind of like mixing all this, like how can we giving a fairness and then also giving a better efficiency. So here's the idea for scheduling. And same if you look at other slides, you can look at the review, try to answer all these questions. Now just like keep on like moving forward about the coming slides. So we'll talk about some like development leading to the modern operating system. So we will discuss the key design area and trends. Okay, that have been like instrumental in the development of the modern operating systems. Here's some elements and trends in OS design. Okay, so five category. Okay, so one is the microkernel. Okay, this architecture, and of course we talk about the multi-threading. Okay, it's really important, and also the symmetric multiprocessing. Okay, if you remember, currently we talk about the symmetric multiprocessing. Also the distributed operating system. Okay, and then last one is the object-oriented design. And when we move on, when we talk about the different architectural approach, so we talk most of the OS. Okay, so even like relatively recently, so kind of like we call the I feature a large like monolithic kernel. Okay, so we try to implement as a single process. Okay, with all the elements of the OS that share the same address space is the idea. And in the modern design, also we try to use like microkernel architecture approach, this one. So we try to only assign only a few essential functions to kernel. Okay. Later you will know we talk about the structure more, and then you will see some graph. You say like kind of like kernel. Somewhere we talk about kernel is between the hardware. Okay, because for our application, okay, software, we are not directly communicate, right? So if you're learning, we know we are not directly communicate to the hardware. So also kernel is one of the kind of like application helping us to handle like to communicate to hardware. And also with some other like OS services provided by the processors. Okay, so kind of like here, so it's called a microkernel. So only like essential function, and that's it for the kernel. And the next one is the multi-threading. So it's a technique that where the process, so they're executing an application, but they will divide into like threads. Okay, can run concurrently. So this one is not the like we sometimes not saying the program like multi-program, but it's like just one process. Okay, so we try to break down or split it, divide it into like different small threads. Okay. That's the reason how can we like utilize better of the CPU, when we have multi-core. If that process, okay, support multi-threading, then maybe we can assign, okay, this part can assign to core one, and then another part assigned to core two. So they doing them different threads. So we can do a dispatchable like unit of work. Okay. So for the process, it kind of like collect of like one or more like threads. Okay. So here's the unit to which should resources they are allocate. So when we load one process, and then we can divide into multiple thread. Okay. And load into the different core. Okay, so once they complete and return, so we can combine together, waiting for the result. So here's the idea of the multi-threading. Oh, actually, that's like the modern computer. Right now, even your like Windows 11, Windows 10, they're all doing right now. Okay, but for the developer of the applications, they also need to try to make this program support multi-threading. Okay. And if you remember, we talked about the symmetric. Okay, here's the SMP. Okay, symmetric multi-processing. Okay, so kind of like we call it just say we have more or two or more symmetric processors. Okay, so working together. So kind of like it's the more working on the hardware architecture. So we make the like SMP OS like can be like exposed that architecture. So it's not really complicated. And before the multi-core comes out, we have the SMP. That means that okay, we put several CPU together. Okay, and then on one motherboard. Okay, so that's why we need the SMP OS helping manage it. Okay, let them work together. But I think nowadays it's not pretty common at all. And we have one is called a distributed OS. Okay, so most of OS they are local, but nowadays I think pretty a lot. If you know, in maybe most of them like campus, maybe some library computer. Okay, maybe some like organization. Okay, once you um press a button, okay, turn on the computer. So it try to loading a copy. So this one compare. So most of them like when we say local, so they just like have stay everything like in the local main memory. But like with the advent of a high-speed network, or like in some organization or like campus, because they can create the OS like of the separate computers, so they can have like separate memories. Okay, so they are not really connected by a bus. Okay, so but kind of that one is a loading the image. That's it. So you can take in the idea, but this one is the distributed OS. Just imagine it is your if you try to use the remote desktop, there's that kind of idea. So what you controlling just the UI. Okay, you can see okay the display, but the control is like the OS is somewhere. Okay, so here one thing is that we need to suppose the network is fast enough. Okay, so just imagine it's a bus. Okay, I would say it's more long time ago, like few years ago, actually, I think distributed file system or OS actually is a pretty hot topic. I think why not, especially for the network, like why not the speed is fast enough. Okay, doing it, but still maybe not everywhere. Okay, depends on like location or some organization they try to do it in this way. So you may not see it, but if you pay attention, there's something similar. And then we have the one we talk about is the object-oriented design. So we always talk about OOY. So object-oriented programming. So it's like relatively more like recent way organizing and writing large software engineering project. So also has been applied to OS design too. So it share kind of like similar, some similarity to small like microkernel approach. If you remember, with a microkernel, only some like small function, okay, to the kernel. And at the OS level, so when we talk about the OS-based structure, so it can help to manage the complexity and enable like programming to customize OS without disrupting the system integrity. Okay, so if you know the old, that means like for this object, it owns certain property, okay, certain action by function, and maybe you can read the value, okay, and then we can using kind of get, and then you can have a like update function, okay, update the variables. So here's the idea. And if you see the window, check your window system, maybe sometimes like open to other program string, then maybe like we can doing actually in the OO structure is the idea. And kind of like almost last part, we look at the, like the Microsoft, like Windows right here. So what are the components? Design mostly use the desktop OS for the Windows. Okay. Look at the history, but you say start from the 1991, like MS-DOS, and then Windows 3, 95, 32-bit. Okay. And start from Windows 3 over there is 16-bit, and then come with the GUI, the GUI, and then 95 30-bit, and the NT still 30-bit OS 2000. Okay, so increase some service. Okay, support distribute processing. Okay, add more. And then there's some like plug and play and power management facilities. And I think there's a really start from XP. So we did like 2001. Okay. So it replace a version like Windows-based like MS-DOS and then with the OS base, right? And then later Vista, but it really have a short life. And of course, for the Windows also they have some Windows Server, but it's not like common for the most computer user. And most of the people they upgrade from Windows XP to Windows 7. Okay, after kind of like 8 years later. So also they also upgrade the Windows Server like 2008 R2 if you have it, and also Windows Azure. And this kind of like targets a cloud computing. Even right now is a big project. Like you can subscribe and use it. And here give you a picture of the Windows architecture. So of ways like we talk about, you remember the hardware, right? So hardware abstraction layer. So in the bottom, and when you hear the terms of what's kernel, so the kernel is right here, this part. Okay, it's like kind of helping you communicate between the hardware. And then next, right here, we do have something like called a driver. Driver right here, we sometimes we call them modules, right? Or IO modules. So including the device file system driver helping us. And the Win32, if you look at your Windows, we have some like user GDI, or those are required library files. And also graphic driver, so it's the bottom right here, kernel mode, like callable interface. We can call it, okay, something like file system or this cache. Okay, lower level, and then system surface and expressor and kernel model. So system third right here. And what's the dynamic loading, the library, so including right here DLL. Okay, and here's is the bottom, so you can here's a color kernel mode, right? And for the user mode, so that's what you see right here. So maybe some system support process, you can see some like service manager. Okay, when log on, okay, session manager, or some EXE like Win manager right here, service .exe right here related service, some applications related task manager. If you know the Windows Explorer, okay, open some files, folders, user applications. Okay, so all this will be the structure. So one is the user can handle it with the kernel. Okay, and what's the kernel mode like components of the Windows? This one is the, when we talk about Windows, is the your most of the Windows user. So it's the executive, so it's like contain the core OS surface. The kernel, it will control the execution of the processor. Okay, how is a called hardware abstraction layer. So it kind of like mapping between the generic hardware commands and response, and those are unique to a specific platform. So this like kind of helping us to handle it. So between the hardware, okay, and then the device driver. So we're loading some dynamic library, so extend the functionality of the executive. Okay, so right here will be the driver. Also the windowing and graphic system. So how us to implement the GUI function. Okay, and above you will see the user mode process. So basically we have four basic types when we go through say special system process, surface process, environment subsystem, and user application. Why not we look at the names, then you can refer to right here. Okay, so there's already common subsystems there now. And when we keep going, we will see something like called a client server model. Okay, so what's the client server model? So we have OS service, provide some environmental like subsystems and application. So they are structured using the client server model. So what's this? So common in distributed system. Okay. We can be like used like to internal and then to a single system. And those that process and can communicate like through the RPC. Okay. And what's the advantage like providing the client server model? Is like it's really simplified the executive. Okay. Also, it can improve the reliabilities. Also provide uniform. Okay. It means like if the application they need to communicate with the service, just like sending the RPC without like restricting the flexibility. The idea is right here because we have server kind sending to it, server receive request, then it happens to perform it. Also, it can provide some suitable base for like distributed computing. So it's also okay. So he's called the client server mode. And now when we talk about the threads, right? Multi-threading, if you remember, we talk about, and then the SMP. So there's two important characteristic of the Windows. Okay, some of them maybe you don't know, but because like it's like an old design, so you just need to have some idea of it. It's okay, just know. So also the SMP symmetric multiprocessing. So the OS routine, so can run any available processor, and different routine can execute like simultaneously on different processors is the idea. Okay, because if we support SMP, that means like on one board we have like different processors like individually, right? And also Windows supports the use of multiple threads. Okay, so we say one processor can divide into small pieces. So the threads of execution, so within a single process, so multiple threads within the same process, so they may execute on different processors simultaneously. So that means that we can work together as what we said before. And server process, so may use like multiple threads to process requests. So for more than one client. Okay, so you see, this is a pretty same idea. They can serve right, but multi-thread thing is we apply this concept. Also, Windows provide the mechanism to share data resources between processes, and also flexible in the inter-process communication capability. So it's like providing, and kind of like summarize right here. We talk about the Windows the objects. So Windows try to like just like heavy on the concept of overall design, object oriented. So the key object-oriented concept. So you really used by the Windows like encapsulations. Okay, so right here, of course, if you learn in Java, if you know, encapsulation is one thing. Object class and instance, which are create inheritance, is a feature of the object like class, right? So we can inherit it. Okay, polymorphism. Okay, also is the actually is the kind of like concept like inherited from the OO design. Okay, there's a pretty similar. So far that's it for this lecture, and we already cover for the our like introduction of the operating system, why it's so necessary. And then later we'll move on to the new chapter. Thank you.